Good day, students. Today I want to solve problem that involves WAEC questions that has been causing confusion to students. Now to use their critical thinking in solving the problem. We are going to see them now. Explain how a tightly fitted glass stopper could be removed from a reagent bottle. What we need to do is to get a warm water and put a warm cloth inside it and wrap it around the reagent bottle mouth. By the time you wrap it around, the mouth of the reagent bottle will expand. It makes you to find it easy to remove the cork out of the reagent bottle. You can see, to remove a tightly fitted glass cork from a reagent bottle, warm the bottle neck using warm cloth to make the glass bottle to expand, creating space for easy removal of the cork. The second question, explain why containers with tight fitting lids are not suitable for use in microwave cooking. Okay, when you have a tight fitting lids, when you are making microwave cooking, it's when you increase the temperature, when the temperature of the cooking starts increasing, and you see that the steam, the molecules of the steam start having collision with the walls of the container, thereby increasing the pressure inside the microwave cooking pot. Before you see, since there it is well tightened, it will increase the pressure to the extent that the container will burst and the content will get released to the environment, which is very dangerous. The container, let's see, container with tight fitted lids are not suitable because with increase in temperature, the steam molecules from the container are confined in the container, thereby increasing the rate of collision of the steam with the walls of the container, hence increase in pressure inside the container. So the high pressure can burst the tightly fitted container and the contents, the hot content released. Okay. Now let's see the third one. When the soup is brought out and allowed to cool, a dent is observed on the container. Explain. Okay. When the observed dent on the container is due to the condensation of the steam in the container, which will lead to a decrease in pressure in the greater container, making the atmospheric pressure greater than the pressure in the container. There will be condensation due to the condensation of the steam in the container. Is that okay? Now let's now see the fourth question. That's a quantity of pepper soup of mass of 800 gram. Convert it to the standard unit because we are giving inside this place, we are giving in joules per kilogram. The unit of specific capacity is in joules per kilogram per Kelvin. Now, since it's in kilogram, joules per kilogram per Kelvin, you have to convert this mass of the soup. Let's call it MS for soup as 800 divided by 1000 because 1000 gram make 1 kilogram. Okay, you have 0.8 kilogram. We got that one from 1000 gram make 1 kilogram. 800 gram will now be what? This times this divided by this. That's 800 times 1 divided by 1000. That's how we got this. Next one, the temperature. It has a temperature of, that's initial temperature theta 1. Just 30 degrees centigrade. Theta 2, we don't have it. Okay. You can now say change in temperature is equals theta 2 minus theta 1. Okay. What again? We are giving rated power. We are giving power to be 1200 watts. Time, that's 3 minutes. Equal to 3 times 60, which is 180 seconds. You have to convert to seconds. That's the standard. Calculate the final temperature. We are looking for final temperature, which is theta 2. Okay. Now, attained, and you are giving specific capacity to be 4000 joules per kilogram per Kelvin. Now, from here, you are going to You are going to relate the equation together. A quantity of pepper soup of mass is poured into a plastic container with a tight fitting lid as a temperature of this. The container is then placed in a microwave oven. Okay, heat gain by soup equals to heat lost by the microwave oven. Heat lost by the microwave oven, because it is soup that gains the heat. Let's see a quantity of pepper soup of Maldives poured into a plastic container with a tight fitting lid has a temperature of this. Now the container is then placed in a microwave oven because we want to warm it. It is soup that gains the heat. Is that okay? Rated this 1200 watts and operated for this time. You now say PT equals to MC change in theta. What's the power? The power. Now, since we are picking this one first, let's make it MC change in theta. It will be for this MC change in theta. This heat lost by the microwave oven, because we are using power, electricity to power it, is the one that we have PT. Now, what we are going to do, what's the mass? The mass of the steam, specific is capacity, the mass of the soup, the capacity of the soup, and the change in temperature. This is the power of the microwave. Mass of the steam is 0.8 times specific capacity. What do you have as that? 4,000 times temperature change equals power 1,200 times time, which is 180, divided both sides by this 0.8 times 4,000, 0.8 times 4,000, cancel this. Change in temperature equals, when you multiply, you have 216,000 divided by 3,200. When you divide, you have 67.5 degrees centigrade. Okay, now since we know that change in temperature equals theta 2 minus theta 1, and we are looking for the final temperature, take theta 1 to the other side. Change in temperature equals, change in temperature plus theta 1 equals theta 2. Now theta 2 equals, what's our change in temperature? 67.5 degrees centigrade plus, what's our theta 1? 30 degrees centigrade. Therefore, theta 2, which is what we are looking for, final temperature, equal final temperature equals 30 plus that's 60, 70, 80, 90, that's 97.5 degrees centigrade. This is the end of our class. Please subscribe to my channel so that I can have access to the latest video. Have a wonderful day.